NEC 110.26 mandates working space in front of electrical equipment to ensure safe operation and maintenance. The required clearance depends on the equipment's nominal voltage. For equipment rated at least 250 volts, the requirements are 42 inches in front, 30 inches wide, and 78 inches high. For equipment rated under 250 volts, the requirements are 36 inches in front, 24 inches wide, and 78 inches high. It is important to understand that NEC 110.26 applies to electrical equipment. Remote devices, such as variable frequency drives or VFD, motor starters, and disconnect switches, are considered electrical equipment and, therefore, generally require working space. It is understood that applying NEC 110.26 as strictly to all remote devices in a conveyor system could be impractical. However, the code does provide exceptions where necessary. NEC 110.26a1 provides an exception permitting reduced working space if certain conditions are met. Firstly, the equipment must be in a dedicated electrical room or area. Secondly, the equipment must be accessed only by qualified personnel. Thirdly, the equipment must be permanently labeled "Do Not Open" energized. NEC 110.26a2 provides an exception permitting reduced working space if the equipment is on a balcony, lift, or similar elevation that provides safe access. NEC 110.26a3 provides an exception permitting reduced working space if the equipment is located in a service chase, utility tunnel, or other location that provides safe access. It is important to note that some local amendments exist, such as the New Mexico Amendment to NEC 2005, which allows for reduced working space for disconnects that do not provide overcurrent protection. However, this amendment would not typically apply to VFD or motor starters, as they generally provide overcurrent protection. Regarding the apparent discrepancy between 3.5 feet and 42 inches in NEC 110.26a, this is simply due to the use of both metric and imperial units. 3.5 feet is the equivalent of 42 inches. For compliance purposes, one should use 42 inches as the required clearance. Given the scenario where a VFD and disconnect switch enclosure has only 30 inches of working space in front of it, and this is not feasible due to the constraints of the conveyor system, several options should be considered. Exception 1 is to install the enclosure in a dedicated electrical room or area with restricted access and label it "Do Not Open" energized. Exception 2 is to mount the enclosure on a balcony or lift that provides safe access. Exception 3 is to install the enclosure in a service chase or utility tunnel that provides safe access. If none of these options are suitable, reaching out to the local authority having jurisdiction, or OJ, for guidance on an acceptable alternative solution is recommended. Remember, the primary goal of NEC 110.26 is to ensure the safety of qualified personnel who may need to work on or near energized electrical equipment. Therefore, any solution should prioritize safety while also being practical and feasible within the constraints of the installation. In a typical industrial setting, several factors contribute to the complexity of applying NEC 110.26, especially within conveyor systems that span large areas. The layout of conveyor systems often necessitates the placement of electrical components in confined spaces. These spaces might include areas beneath or between conveyor sections, making it challenging to achieve the required clearances. The presence of other equipment and structures around the electrical components can further restrict the available working space. Conveyor systems often have complex support structures, safety barriers, and other machinery that can obstruct access to electrical enclosures. The need to maintain the operational integrity of the conveyor system can also limit the ability to relocate electrical components. Shutting down a conveyor line to move an enclosure can disrupt production and cause significant downtime, making it a less desirable option. The type of equipment being installed also influences the application of NEC 110.26. VFDs, motor starters, and disconnect switches come in various sizes and configurations. Choosing the smallest possible enclosure that meets the necessary requirements can help minimize the space needed and make compliance with NEC 110.26 easier to achieve. The environmental conditions where the electrical equipment is located can affect the type of enclosure required. In dusty or wet environments, enclosures must be rated to protect the components from these elements, which can further increase their size and complexity. The qualifications of the personnel who will be accessing and working on the electrical equipment are also an important consideration. If only qualified personnel will have access, the exceptions in NEC 110.26 may apply, allowing for reduced working space. In such cases, proper training and safety procedures are essential to ensure the safety of the personnel. The frequency of maintenance and repair activities on the electrical equipment should also be considered. If the equipment requires frequent maintenance, it is important to provide adequate working space to allow for safe and efficient access. However, if the equipment is relatively maintenance-free, the need for working space may be less critical. The long-term implications of the installation should also be taken into account. As conveyor systems evolve and change over time, it is important to ensure that the electrical components remain accessible and safe to work on. This may require periodic reassessment of the working space and adjustments as needed. In some cases, it may be necessary to implement additional safety measures to compensate for reduced working space. These measures may include the use of insulated tools, personal protective equipment, and lockout-tagout procedures. It is important to document all safety measures and ensure that they are clearly communicated to all personnel who may be working on or near the electrical equipment. In situations where strict compliance with NEC 110.26 is not feasible, it is important to work closely with the local AHJ to find an acceptable alternative solution. The AHJ may be willing to grant a variance or waiver if it can be demonstrated that the alternative solution provides an equivalent level of safety. To obtain a variance or waiver, it is typically necessary to submit detailed documentation to the AHJ, including drawings, specifications, and a safety analysis. The documentation should clearly explain why strict compliance with NEC 110.26 is not feasible and how the alternative solution provides an equivalent level of safety. It is also important to be prepared to answer questions from the AHJ and provide additional information as needed. Obtaining a variance or waiver can be a lengthy and complex process, but it may be necessary in order to install and operate a conveyor system safely and legally. Remember, the goal is to strike a balance between safety, practicality, and compliance with the electrical code. In specific cases, alternative solutions to achieve electrical safety compliance within the constraints of conveyor systems could include: firstly, using smaller, more compact electrical enclosures to house VFD, motor starters, and disconnect switches. These enclosures can be easier to fit into tight spaces and can help minimize the working space required. Secondly, relocating electrical components to more accessible locations, even if it means running longer conduit runs or making other modifications to the system layout. This can improve working space and make it easier to comply with NEC 110.26. Thirdly, using flexible conduit or cable trays to route wiring and cabling around obstructions, making it easier to access electrical components without having to remove or disassemble other parts of the system. Fourthly, installing remote monitoring and control systems that allow personnel to monitor and control electrical equipment from a safe distance, reducing the need to access the equipment directly. Fifthly, providing additional lighting in areas where electrical equipment is located to improve visibility and make it easier to work safely. Sixthly, implementing a comprehensive lockout-tagout program to ensure that electrical equipment is de-energized before any work is performed on it. Seventhly, providing regular training to personnel on safe work practices and the proper use of personal protective equipment. Eighthly, conducting regular safety audits to identify and correct any potential hazards. Ninthly, establishing clear communication channels between maintenance personnel, operators, and supervisors to ensure that everyone is aware of any potential safety issues. Tenthly, documenting all safety procedures and making them readily available to all personnel. By implementing these measures, one can create a safer working environment and reduce the risk of electrical accidents, even in situations where strict compliance with NEC 110.26 is not feasible. Another approach to the problem involves a detailed risk assessment. A thorough risk assessment should be conducted to identify potential hazards and evaluate the likelihood and severity of accidents. This assessment should consider factors such as the voltage level, the type of equipment, the frequency of maintenance, and the qualifications of the personnel who will be working on the equipment. The results of the risk assessment can be used to develop a safety plan that addresses the specific hazards associated with the installation. This plan may include measures such as reducing the voltage level, using intrinsically safe equipment, providing additional training, and implementing enhanced safety procedures. The risk assessment should be reviewed and updated regularly to ensure that it remains relevant and effective. It is also important to involve all stakeholders in the risk assessment process, including maintenance personnel, operators, supervisors, and safety professionals. This will help to ensure that all potential hazards are identified and that the safety plan is comprehensive and effective. By conducting a thorough risk assessment and developing a comprehensive safety plan, one can create a safer working environment and reduce the risk of electrical accidents, even in situations where strict compliance with NEC 110.26 is not feasible. It is also useful to explore alternative technologies. Advances in technology have led to the development of new types of electrical equipment that are smaller, more efficient, and safer to operate. These technologies can help to reduce the working space required and make it easier to comply with NEC 110.26. For example, solid-state motor starters are smaller and more reliable than traditional electromechanical starters. They also generate less heat, which can reduce the need for ventilation. Similarly, variable frequency drives can be used to control the speed of motors, reducing energy consumption and improving efficiency. VFD also provide built-in protection against overloads and short circuits, which can reduce the risk of electrical accidents. Another technology that can be used to improve safety is arc-resistant switchgear. Arc-resistant switchgear is designed to contain and extinguish electrical arcs, preventing them from spreading and causing damage or injury. This type of switchgear is particularly useful in high-voltage applications where the risk of arc flash is high. By using these and other advanced technologies, one can create a safer and more efficient electrical system, even in situations where strict compliance with NEC 110.26 is not feasible. Furthermore, proper documentation and labeling are crucial. All electrical equipment should be properly documented and labeled to ensure that it is easy to identify and understand. The documentation should include drawings, specifications, and operating instructions. The label should clearly indicate the voltage level, the type of equipment, and any potential hazards. The documentation and labeling should be kept up to date and readily accessible to all personnel who may be working on or near the electrical equipment. It is also important to use standardized symbols and terminology to ensure that the documentation and labeling are consistent and easy to understand. In addition to documenting and labeling the equipment, it is also important to document and label the wiring and cabling. The wiring and cabling should be clearly identified with wire markers or labels that indicate the circuit number, the voltage level, and the destination. This will help to prevent confusion and reduce the risk of accidental disconnections or misconnections. By properly documenting and labeling all electrical equipment and wiring, one can create a safer and more efficient electrical system.